For today's class, we will be covering section 4.5, which is on graphs of sine and cosine. So now that we know how to work with these two basic trig functions, we can talk about what their graphs look like. Our first task is to graph the basic cosine function for values from negative 2 pi to positive 2 pi, and we'll use our unit circle to help us here. So the first thing that we are going to do before we graph is let's make a table of values, and then we'll look at what the graph looks like. So we know that the domain of cosine is all real numbers, so I can pick anything I want, but let's pick values that give us nice outputs. Let's start at 0. We'll worry about graphing from negative 2 pi to 2 pi when we put it all together. So I have t values, and I have outputs, which are the cosine of t. So what is the cosine of 0? If I look at my unit circle, the angle 0 lands over here, so the cosine is the x value, which is 1. Now, I could plug in pi over 4, but if I do that, the cosine of pi over 4 is the square root of 2 over 2, and that's not an easy value to find on a graph. So let's pick nice values. If I plug in pi over 2, the cosine of pi over 2 is 0. And I can keep going around my circle. Again, I could plug 2 pi over 3 or 3 pi over 4 in, but then I won't get nice, easy to graph values. I can jump over to pi, and the cosine of pi is negative 1. I can jump down to 3 pi over 2. The cosine of 3 pi over 2 is 0. And then I can also come all the way back around my unit circle. The cosine of 2 pi is the same as the cosine of 0 because they're coterminal angles, which is 1. Let's make some room for our graph. We'll keep our chart up in the corner. We'll draw our x and y axes, and we will mark some values. So we know the range of the cosine function is from negative 1 to 1, so we can label our y values. And we decided to pick values of 0, pi over 2, pi, 3 pi over 2, and 2 pi. So if I graph on the positive x-axis to 2 pi, then half of 2 pi is pi, right, halfway around the unit circle. Half of that is pi over 2, so I have pi over 2, pi, 3 pi over 2, and 2 pi, just like I have on the unit circle. Now we can put our points in from our table. I have the point 0, 1, pi over 2, 0, pi, negative 1, 3 pi over 2, 0, and 2 pi up at 1 again. If we connect these with a smooth curve, here is what part of our cosine function looks like. We know it won't keep going past positive 1 because that's the biggest that the cosine function can be. Now the original question asked us to graph cosine between negative 2 pi and 2 pi. So we have the graph right now from 0 to 2 pi, but we also want to go the other direction. Let's go off to the side for a minute and make another table that captures some negative angles. So we still have t and cosine of t, but if I go around the opposite direction, if I go around in the clockwise direction, I can go to the angle negative pi over 2, and on our unit circle, negative pi over 2 is down at the bottom, and the cosine value is 0. If I keep going, negative pi lands me on the left-hand side of the unit circle. The cosine of negative pi is negative 1, and I keep going. The cosine of negative 3 pi over 2 is 0, and the cosine of negative 2 pi is 1. So let's go back to our graph and add these values to our graph. So we're going all the way to negative 2 pi. Well, half that is negative pi. Half of that is negative pi over 2. So we have negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. And if we follow our chart, the cosine of negative pi over 2 is 0. The cosine of negative pi is negative 1. The cosine of negative 3 pi over 2 is back at 0. And the cosine of negative 2 pi is 1. And we can connect our points with a nice smooth curve. And again, I know that I won't be going above 1 here. I know that the graph will eventually fall again. So as a final touch, we can add some arrows to the ends of our graph here, and we will see this repeating wave pattern if we kept going, right? Because if we kept going and added more values past 2 pi, all we're doing is going around the unit circle more and more times, but we know that we'll keep bouncing between this 1 and negative 1. Now on the bottom of page 1 of your notes, you have a couple of blanks to fill in. Notice that we have this repeating wave pattern. This is a function that's called periodic. A function is called periodic if it repeats its values over regular intervals. And the period of a function is the amount of time that it takes for the function to complete one full cycle. So if we think about one full cycle, it happens right here between 0 and 2 pi, right? Because after 2 pi, I'll start to come down again and I'm just repeating my values along the unit circle. So it should make sense that going around the unit circle once will correspond with one full cycle, because if I go around again, I just start repeating my values. So the length of the interval of this one cycle is 2 pi. So the period of the cosine function is 2 pi. So when we graphed this function from negative 2 pi to positive 2 pi, we graphed 2 full periods of the function. From this graph, we can confirm a few things that we know already. We already talked about the domain and the range of cosine. The domain is all real numbers, right? We have our arrows on either end, so the graph will just keep going. And the range of cosine is from negative 1 to 1, right? I have no values below negative 1 and no values above positive 1. We can also see that this graph is nicely symmetric about the y-axis. Remember that functions symmetric about the y-axis are called even functions. Pause the video here and fill in the rest of the notes on page 1 and then flip to page 2. Page 2 asks us to graph the sine function also from negative 2 pi to 2 pi. Again, the domain of the sine function is all real numbers, so we can put in any values that we want, but if we take the sine of angles that have nice y values, then it's easy to graph them. So let's pick multiples of pi over 2 again, some positive and some negative. Pause the video, fill out your chart with the sine values, and then hit play again. Now that you have your completed chart, let's take a look at the graph of the sine function. So we have our x and y axes set up again. Remember that the range of sine is from negative 1 to 1, so those are the only y values that we need to label here. And we have our x values from our table labeled, or our t values. So if we go through our table, the sine of 0 is 0. The sine of pi over 2 is 1. The sine of pi is 0. The sine of 3 pi over 2 is negative 1, and the sine of 2 pi is 0. If I go in the opposite direction, the sine of negative pi over 2 is negative 1. The sine of negative pi is 0. The sine of negative 3 pi over 2 will interfere with my chart, but that's okay. And the sine of negative 2 pi is 0. Let's connect these with a nice smooth curve. And you'll notice that it looks very much like the graph of the cosine function. Again, we can say a few things that we already know. You can see that the domain of the sine function is all real numbers. It keeps going in both directions. and the range is from -1 to 1. We didn't go above 1 or below -1 on the y-axis. We can also see that the sine of t is an odd function because it's symmetric about the origin. We can also talk about the period of the sine function the way that we did with the period of the cosine function. So the period is the length of one full cycle. So if we highlight one full cycle here, in orange we have one full cycle. If I continue on past 2 pi, I'm just going to start repeating myself. So just like in the cosine function, the sine function has a period of 2 pi. Pause the video, answer the questions on the bottom of page 2, and then hit play again. Okay, so we know what both the sine and the cosine functions look like. Here's a graph that shows them together so that we can talk about the relationship between the two. The two functions look very similar. They have the same domain, they have the same range, and they have the same repeating wave pattern. If I think about picking up the sine graph, which is here in red, and moving it to the left, pi over 2 units, do you agree that I would land right on the graph of cosine? So we can say that the graph of sine is a horizontal shift of the graph of cosine pi over 2 units to the right. Because if I picked up the cosine function and I moved it pi over 2 units to the right, I would land right on top of the sine function. So there is a nice connection between the two concerning horizontal shifts. Pause the video and fill out the last question on page 2 and then hit play again. Flip to page 3 of your notes. Just like all of the other functions that we've talked about, we don't just talk about the basic function, we talk then about transformations of that basic function. So let's talk about transformations of the sine and the cosine function. All of the transformations that we'll talk about are the same ideas from section 1.6, things like vertical shift, horizontal shift, reflecting, stretching, and shrinking. Some of the names and the words that we use will be different though. So the general form for the sine and the cosine functions are here in orange. Y equals a times the sine of the quantity bx minus c plus d, and y equals a times the cosine of the quantity bx minus c plus d. Let's go through what each one of these letters represents, and we'll use this graph to the side of one period of the sine function to illustrate some of these things. So a has to do with how tall the graph is. If you think about what we know, a, the number in front of our function, deals with stretching the graph, shrinking the graph, and possibly reflecting the graph. We have a new term here. The absolute value of a is called the amplitude of the graph. This is the height of the wave from the middle of the wave. So if we think about here, the middle of our wave on the sine graph is just our x-axis, and the height is the middle of the wave to the top, or in the other direction, the middle of the wave down below. So the amplitude is equal to 1, which makes sense because the number in front of the sine function here, this is like saying 1 times the sine of theta. So again, the same thing applies that we learned from section 1.6, that the number in front of the function tells us whether our function stretches, shrinks, and of course if it reflects. So if a is negative, then the graph is reflected about the x-axis. A few minutes ago when we were graphing the sine and the cosine functions, we talked about the period. The period of the sine and the cosine functions has to do with this number b in front of the x. But that's not all it has to do with. The period is given by 2 pi divided by this b value. So if you think about the period of the sine function, b is equal to 1, and we already said that the period of the sine function without any transformation is 2 pi. So if you need to calculate the period from the equation, we have a nice little formula for it. The next thing we have to talk about is whether or not our graph gets shifted left or right, and we talked about that a little bit with the connection between the sine and the cosine graph. The horizontal shift, when we talk about sine and cosine and periodic functions, is called the phase